I watched the movie San Andreas, and I have to say it's a pretty darn good movie. The character development was awesome. The graphic effects were awesome. Everything about the movie was awesome and amazing, but the science. The science was totally screwed up. Here's why. The San Andreas fault is a strike strip fault, which means the two faults rub against each other. And these kind of faults generate earthquakes frequently, not over hundreds of years, with the subduction zone faults, known as thrust faults. This is the strike strip faults have frequent but less severe earthquakes than the subduction zones. You could get an 8.0 every 1 to 200 years on a strike strip fault, while on a subduction zone you get much rarer but much more stronger and severe earthquakes. Case in point, the Cascadia Fault. 300 years ago, there was a tsunami that was reported in Japan around 1700. And the thing is, in Japan, people are used to earthquakes before tsunami. They're used to a tsunami following an earthquake. 1700, there was a tsunami without an earthquake, which puzzled people in Japan back in 1700. And today, and recently, a scientist tried to figure out what would cause a tsunami to hit Japan without an earthquake being generated nearby. The scientist theorized that it came from the United States, around the Pacific Coast area, due to the orientation of the tsunami. And recently, no evidence was found until now. The geologists found tree rings on the coast of Washington State, and all the trees went dead around 1700 due to a tsunami. The Cascadia Fault, unlike the San Andreas, is a subduction zone. It's a thrust fault. All of the world's strongest earthquakes, the Chile 1960 earthquake, the Sumatra 2004 quake, the Good Friday earthquake of 1964, and the more recent Japan quake of 2011 were all subduction zone earthquakes, which means one fault slides under the other like this. And this generates mountain ranges. And here's what happens. So as one fault slides under the other, friction is generated because it's more of a direct collision. The motion is severely stifled, which means more energy is able to build up. Like when you pull a rubber band, it stretches and then you let go, and all the energy is suddenly released. San Andreas, as I said, does this more frequently. So it's not as strong. So you could get maybe an 8.0, 8.5 at worst. Because the 1900 San Francisco earthquake is really as bad as it can get. But for people living on the west coast, northwest coast of Seattle, of Washington and Oregon, they have a lot to worry about. Why do we have the Cascadian Mountains? The Cascades, that's because of the Cascadian Fault, which is ramming into the North American Fault. And should that fault go, we can have a major quake. I don't mean 8.5, 8.8. I mean 9.0 or greater. I mean extremely major. I mean, like, we could even have 9.5 because of the energy that's been building up over so many hundreds of years. Not over a few decades, maybe 100, 200. No, I mean at least 300 years already. It's been actually 400 years. 1800, 100 years, 1900, and 2000. It's been over 300 years. It's already closing into the 400 mark, We're already going to the 400. So, and all that energy is just building up. It's going to release a gigantic quake. Should that fall rupture, my God, I mean, that is going to be a horrible disaster. It could be as powerful as the Good Friday quake. If that quake strikes, the death toll on the West Coast would be in the tens of thousands. Here's what would happen. You'll get a 9.5 quake, or 9.4. You get something close to 9, maybe even the low 9s. You're going to have a major tsunami that's going to crash into the West Coast. Seattle, the tall buildings are going to survive, like the good reinforced buildings, but the viaduct in Seattle will not survive. the viaduct will collapse because the viaduct is a two-lane road. It's a two floor road, like the viaduct in San Francisco. It's gonna pancake. It's gonna trap cars that are gonna be in the bottom floor. So, and even the cars at the top of the road could buckle and cars could fall in. If you've watched the footage from the 1989 Loma Prieta earthquake, you would understand what I'm talking about. It's going to be terrible. There's also Northridge Quake. The same thing happened. That was another San Andreas quake. Actually, no. The Northridge Quake was actually not San Andreas. Excuse me about that. That was actually the Northridge fault, newly discovered fault. But the thing is, it can rupture the Cascadia fault could unleash one of the strongest earthquakes in modern history, and it could even cause tidal or waves will ripple around the whole world. And actually, in the 1964 quake, actually caused it was actually even wells in other parts of the world were actually shifting because of this quake. That's how strong the quake was. And the Chicago, I heard that the ground actually rose and fell 2 inches during the quake. As the quake wave passed, as the seismic wave passed Seattle, Washington, Chicago. Should this fault rupture, Seattle is going to be devastated. I mean, the Space Needle could actually collapse. Some of the taller masonry buildings in Seattle will collapse definitely, and Seattle could actually might have a tsunami, even though it's protected by more land west of the Puget Sound. That piece of land could actually be what does in Seattle. With such a powerful earthquake, there's going to be numerous landslides, and all it will take is one significant landslide in the Puget Sound to trigger a big tsunami that could just wipe out Seattle. And it could be just like in the movies San Andreas. What the movie San Andreas really depicted is what could happen to Seattle should the Cascadia fault rupture. That will be Seattle. That will be Portland should the Cascadia fault rupture. This movie just didn't take in the Cascadia fault because the Cascadia fault isn't as well known as the San Andreas. But this type of earthquake will definitely do in Seattle. Well, thank you for watching. Have a great day. And please go see San Andreas. It's a great movie, just the science is off. Other than that, amazing movie. I loved it.